Hello, welcome to the last day of the unit. Today we're going to be learning about oblique asymptotes. Now we knew with n behavior that if the denominator is less than the degree of the numerator, our horizontal asymptote is y equals 0. We also learned that if the degree of the numerator is the same as the degree of the denominator, so say x is x to the n over x to the n, we take a over b, we take the coefficients of those, so y equals a over b is our horizontal asymptote. But if the degree of the numerator is bigger than the degree of the denominator, we know that as x goes to positive negative infinity, f of x goes to negative, or goes to infinity somehow. But how does it go depends. Now this one, when we divided by x on all of them, we saw that it was a linear function. And so a linear function is going to go positive infinity to the right, negative infinity to the left. So that's positive negative infinity. But how does it exactly go there? Like, how would we draw that? That's something different. So what we need to do is actually do some polynomial division. So x goes into x times. That would be x squared plus 4x. When I subtract, this becomes negative 1x minus 10. And so that would be minus 1. So negative x minus 4. When we subtract, that changes the signs. So that would be the remainder of negative 6. So this is the same thing as x minus 1 minus 6 over x plus 4. Now, think about this. The limit as x goes to positive and negative infinity of x minus 1 minus 6 over x plus 4. Now what's going to happen to this part of the function as x gets really, really big? Hopefully you're saying this part of the function is going to go towards 0. So really, what this is going to go towards is the equation x minus 1, which is a linear equation. So this will tend to the line y equals 1x minus 1. Now another way we can do this without the polynomial division, since we're just dividing by a linear on this one, we could do synthetic division. So I'll do that quick over here. We'd put negative 4 in the box, and this would be 1, 3, negative 10. And this would be 1, negative 4, negative 1, negative 4, negative 14. Oh, this would be positive 4. So we got negative 6. So we would ignore this part because this would be the part that is here that would go towards 0. So x minus 1 is the same thing we got there. So we call that our oblique asymptote. Y equals x minus 1. Alright, let's try a new problem. Describe this end behavior. Well, when if I would divide by x on all of these, this would be x squared minus 5, which would be a quadratic. So a quadratic that's facing up. So we know that this would go towards infinity, positive infinity, as f of x gets closer and closer to positive infinity. Now let's see what the oblique asymptote is. So since we're dividing by a linear, we can use synthetic division. That would be x cubed. This would be 0x squared, negative 5x, and 0 on the end. So now when we divide, so this is the same thing as x squared minus 2x minus 1 plus 2 over x plus 2. Now let's look at the limit as x goes to positive and negative infinity of this. Well, the limit as x goes to positive and negative infinity, this part is going to go towards 0. So this is going to go towards x squared minus 2x minus 1. So we call this our oblique asymptote. Notice how this isn't a straight line, this is going to be a parabola. So our function, maybe we should draw this one out. That's a good idea. This is x cubed minus 5x over x plus 2. If I looked at this graph, we know that if I factored the numerator, it would be x and x squared minus 5. So we know it has a 0 at 0. Okay, let's do zeros. Vertical asymptote, oblique. And we know the oblique asymptote is y equals x squared minus 2x minus 1. The vertical asymptote is when the denominator equals 0, so that's x equals negative 2. The zeros, well, there'd be 1 at 0, and if I solve this, x squared minus 5, that can simplify into x plus root 5, x minus root 5. So there's 2 more zeros at root 5 and negative root 5. So root 5 is a little past 2. So we have our zeros at 0, a little past 2, or a little past negative 2 there, I guess, and a little past 2. It should be right over there. Our vertical asymptote is at negative 2, so if I drew a vertical line here at x equals negative 2. Now our oblique asymptote is y equals x squared minus 2x minus 1. This can factor into x minus 1 squared. So on the end behavior, x minus 1 squared is a parabola where I go out to the right 1, and it's just our normal parabola. I'm going to do this in blue. So its vertex is going to be here, and then it's going to go up just like the parabola generally goes up. So that's going to be the direction that our graph goes in. Alright, now in black, I should do the sign chart. So we have our zeros at negative root 5, and x vertical asymptote at negative 2, and then at 0 there's another one. So we know on the far left and the far right the sign chart is going to be positive because it's going to tend towards this parabola. At 0, if I plugged in 0 into this function, 0 times anything here would just be 0. So it would be 0 over 2. So at 0, that's a 0. So we don't have to plug 0 in. I don't know why I'm doing that. Let's plug in 1. 1 times 1 squared minus 5, which would be negative, over 1 plus 2, which would be positive. So this would be negative. If we plugged in negative 1, negative 1 times a negative number over a positive, so that would be a positive. So we have a negative times a negative on top. And then if I did like negative 2.1, that would be enough. So this would be negative still, negative, and another negative. So 3 negatives would make a negative. Alright. So what we do here is we start to the left, and it's going to be positive, and it's going to be going towards this parabola. It's going to come down until it's going to hit, this 0, and then it's going to be negative between these values. So then it's going to come closer and closer to our vertical asymptote. Just to the right of that vertical asymptote at 2, it's going to start at the top again, come down until it hits our 0 at 0, and then be negative until it hits our other 0 here. So it's going to come down, hit there, come back around, hit there, and then go up towards our end behavior, which is our blue parabola. Now that's a pretty crazy graph. But if we go out to the left and to the right, it's going to go towards our oblique asymptote, which is a problem. Alright, now let's describe this end behavior. What we do here is to find the end behavior, we actually divide it. So we have x squared minus 3x plus 4 divided into 3x to the 4th minus 7x to the 3rd plus 2x squared plus 6x plus 1. Now pause the video, see if you can figure this out on your own so you remember this. When you're done, just hit play again. Alright, I got 3x squared. This would be 9x to the 3rd plus 12x squared. Now when I subtract, I'll change all those signs. So now I have 2x to the 3rd minus 10x squared plus 6. What times x squared is 2x to the 3rd? That's 2x. So 2x to the 3rd minus 6x squared plus 8x. When I subtract, that changes all the signs. And now I subtract 4. And so we have negative 4x squared minus 12x minus 16. Now we could figure this out, but really it doesn't matter, because what I'm putting over here isn't going to be affected, because the limit as that goes to positive infinity is just going to be that quotient of 3x squared plus 2x minus 4. Alright, now let's try to sketch the graph of this. Now you pause the video, see how well you do on your own, and then we'll go from there. Hopefully you're done. Oops. This is x plus 2, x minus 2, over x plus 3. So to sketch this graph, we know it has zeros at negative 2, at negative 3 is a vertical asymptote. Now, if I want to find my oblique asymptote, x plus 3 divided into that, I can just use synthetic division. So I have negative 3, 1, 0, negative 4. So 1, negative 3, now 9, 5. But this part doesn't even matter, because it's just x minus 3 that is my oblique asymptote. So y equals x minus 3. If I go down 3, I can create my line going up 1 over 1. That's my oblique asymptote. I have my zeros. Now I can make my sign chart, having negative 3, negative 2, and 2 be my points. Now, if we look at this chart to the right, it has to be positive. To the left, since we're going here, it will have to be negative. Between negative 3 and negative 2, say if we put negative 2.5, this would produce a negative answer, a negative, and a positive. So two negatives would make it positive. Between negative 2 and 2, let's plug in 0. 0 would be negative 4 over 3. So negative 4/3 would be a negative. And we could even put that in there right there if we wanted to for a y-intercept. So it's going to be negative between negative infinity and negative 3. It's going to go off in this direction. So we can't go up to that asymptote, so we have to come up here and then come back down. On the right-hand side of this asymptote, it says we have to start at the top, because that's positive, and then we're going to come down, hit this 0. It's going to be negative until it gets to 2, and then it's going to come out towards that line. And here is are oblique asymptotes, or graphing with oblique asymptotes. Wonderful. Hopefully that makes sense, and that's enough to do your worksheet. Good luck.